So the second factor we want to consider is the concentration. The concentration of the electrolytes. How does it affect preferential discharge of ion during electrolysis? So this affects the anions. This affects the anions at the anode, where the ions above the other one is preferentially discharged. Due to the concentration of the electrolytes. We are going to illustrate this with example, so it will affect the anions at the anode. We are going to start with example 1. Let's see example 1, how concentration affects that. So let's see electrolysis of concentrated sodium chloride. So to fight is conc, we call it brine. So anytime you mention brine, it is conc. Anytime conc is added to the question, meaning they want to test the effect of concentration of electrolyte on the preferential discharge of ion. So anytime they mention concentrated chloride or the brine, another name for concentrated sodium chloride is called brine. So please be careful here. You can use, for the cathode we don't have the problem, using carbon electrodes. Using carbon electrodes is correct. Or you can use carbon cathode or platinum cathode, and you must, for the anode, it must be carbon anode, because something will be liberated that will react with platinum. So we don't want that to happen. So here you either use carbon cathode or platinum cathode, correct. Either of the two can be used. But as of anode, it must be carbon anode. That's the major difference. Go and look at the sodium electrolysis of sodium chloride solution using, I said, carbon electrodes or platinum. You can use for dilute sodium chloride. But concentrated one, the anode is made of nothing but carbon, but the cathode could be carbon or platinum to prevent the anode from being attacked by the products liberated at the anode. Please take note of that. It's always, I will put it in a tabular form. So let's see chemistry of reaction. Meaning what happened. Let's see ionization first. Sodium chloride, still remember, we ionize to sodium ion plus chloride ion, followed by water. Water will be hydrogen ion plus OH minus. That is water. That is water. So the next thing we are going to do is to see what happens at the cathode. So at the cathode, sodium ion and hydrogen ion migrate to the cathode. At the cathode, where hydrogen ion is preferentially discharged. So we say hydrogen ion is what? Preferentially discharged. Meaning discharged in preference to sodium, because it is below sodium in the electrochemical series. So we do it like this: hydrogen ion plus electron, remember, to give hydrogen gas. This gas is liberated at the cathode. That is cathodic reaction. Cathodic reaction. At the anode, what and what migrate? Chloride ion and OH minus migrate to the anode. You know, OH is below chloride ion in the electrochemical series, but due to concentration of the electrolyte, instead of OH to discharge, chloride now is preferentially discharged. So we say Ca minus is preferentially discharged. Is preferentially discharged due to the concentration of the electrolyte. So for that reason, Ca minus, as gained before, to now lose electron to be formed Cl. Then Cl can combine with Cl to form Cl. You can use an equation for that by putting 2 here and 2 here. So the equation is balanced. So chlorine gas is liberated at the anode. Chlorine gas is liberated at the anode. So the resulting solution, let's see the resulting solution. The resulting solution contains sodium ion and OH minus, which when they combine together it forms sodium hydroxide, which is basic. So the resulting solution is basic. It contains sodium hydroxide solution. So if we can draw the table for it, let's sketch. Now let's make a table. You can draw the table for it. Here we have electrolyte. Electrolyte is there, meaning concentrated sodium chloride, known as brine. That is what we use. Concentrated sodium chloride brine. That is what we use. So here, 1, 2. What is the cathode and what is the anode? I've told you cathode, you can use platinum, you can use carbon. So if you use carbon here, the anode is always carbon, because chlorine gas will attack platinum. So for that reason we use carbon, or use carbon or platinum here. But here is really carbon. So immediately after that, the gas evolved at the cathode. The gas evolved at the cathode. We have done that. Hydrogen gas evolved at the anode. We have chlorine gas. This chlorine gas, a greenish yellow gas that turns starch and other paper blue-black. We call it a chlorine gas. Vibrated. Then the resulting solution after electrolysis. You know, the resulting solution is basic. which is sodium hydroxide. So what is the effect on litmus paper? Effect on litmus paper is returning from red to blue. The solution will turn from red to blue. Is there any color change? No color change. It's colorless. Change color. Color change. No color change. Still remain colorless. So by the pH, what about to the pH? The pH will be affected. You know, normally sodium chloride is pH of 7. The now sodium hydroxide is a base, so it will have higher pH. So the pH increases. So pH increases and so on. What happens to the concentration? Concentration also increases. So the pH increases. Please take note of that. This is the summary of the table here. That's the summary of the table of electrolysis of brine. Electrolysis of brine, concentrated sodium chloride. Electrolyte, cathode, anode, gas involved at the cathode, gas involved at the anode, resulting solution after electrolysis. So I will now divide it into two. This for sodium chloride solution, and this is concentrated. Let's see the difference now. Sodium chloride solution, concentrated sodium chloride solution. Remember, you can use platinum, you can use carbon, you are correct. That is graphite or platinum. Here also you can use carbon or platinum. None of the product will attack the electrodes. So gas involved at the cathode, if you still remember, go and check. You say hydrogen, here it is oxygen. Resulting solution still contains sodium chloride. But concentrated sodium chloride known as brine. When we did this, cathode, you can use carbon, no problem, or platinum. But here must always be what? Carbon. Please take note of that. What is the gas involved at the cathode? Still remain hydrogen gas. The gas involved at the anode is chlorine gas, while the resulting solution is sodium hydroxide. Please take note of that. This table shows the difference between electrolysis of sodium chloride solution. Remember, where we tested for the position of ions in a chemical series. Here, the concentration of the electrolyte. That's the summary of the table. So that is that. Example 2. Electrolysis of lead-2-bromide. Electrolysis of molten lead-2-bromide. using carbon electrodes. Using carbon electrodes. Take note of that. So the same thing will happen. This one will ionize. We ionize to Lead-2 plus bromine ion. So water, consider water here. This one will be hydrogen ion plus OH minus. What happens at the cathode? There will be migration of opposite charges. So Lead-2 will migrate here, and hydrogen ion. And lead is below hydrogen and is preferentially discharged. So we say Lead-2 is preferentially discharged. Lead-2 ion is preferentially discharged. Lead-2 ion is preferentially discharged. So meaning Lead-2 ion, it has lost electron plus 2 electron now to bring lead. So lead metal is deposited at the cathode. Please take note of that. Let's see what happens at the anode. Call it anodic reaction. Let's see what happens at the anode. Bromine and OH minus will migrate. Due to the concentration, bromine ion is preferentially discharged. So bromine ion is preferentially discharged. So for that reason, we have Br minus. It has gained. You now lose electron now to become Br. So 2 here, 2 here, then bromine gas. And this is a reddish brown gas. Brown gas is liberated. The reddish brown gas is liberated at the anode. This is the electrolysis of molten Lead-2 bromine using carbon electrode. Please take note of that. At the cathode, what happens? Lead is deposited at the cathode, while at the anode, a reddish brown gas, bromine gas, is liberated at the anode. That is the chemistry of reaction. Nature of the electrodes. Nature of the electrodes. Nature. This affects the cations at the cathode. It affects the cations at the place. Take note of why concentration affects the anions at the anode. How? We are going to use example to illustrate this. To illustrate this. Like anytime you have sodium, and let's use example to illustrate it. Example 1. Let's see electrolysis of copper 2 tetrasulfate 6 solution using copper electrodes. You know, the first one we did, we use carbon or platinum electrode. Now copper electrode. This one, we want to test the nature, how the nature of the electrode affects the preferential discharge of ion during electrolysis. So example 1. So let's see chemistry of reaction. You have copper 2 solution, we ionize to copper 2 ion plus SO4 2 minus. Then water we ionize to hydrogen ion plus OH minus. That's what we have. So at the cathode, what happens at the cathode? Copper 2 ion and copper 2 and hydrogen ion migrate to the cathode. And what happened at the cathode? Copper is below hydrogen, so copper 2 ion is preferentially discharged. So plus 2 electrons to give you copper. So in reddish brown copper, this is reddish brown copper is deposited at the cathode. Then let's move to anode. Let's see the behavior. The anode. At the anode, what and what will migrate? We have SO4 2 minus and OH minus migrate. But no ion here. No ion is preferentially discharged. Neither SO4 2 minus nor OH minus will discharge. Though really 3 things are likely to happen, but discharge of SO4 will not take place, OH will not take place. But it's either SO4 is what? Discharge, meaning SO4 2 minus 2 electrons to give SO4 sulfonation, or OH minus 4 here minus 4 electron to give 2 mole of water plus oxygen. Possibility of this being occur, or just say OH using electron to become OH minus to become OH. All this is likely to happen. And the third case is either copper anode goes into solution, dissolves copper 2 sulfate solution to replace the lost copper 2 ion. You know, copper 2 ion, the solution, the cathode has been discharged. So copper anode now will now dissolve in the solution. So this is the reaction that will occur. Copper, this will now become copper 2 ion. So this is what is likely to happen. This is what is likely to happen. We have 2. This is what is likely to happen. So copper will lose electron, will dissolve to form copper 2. This one will go into the solution to replace the lost one. These are the 3 things that are likely to happen. But out of this one will not happen. This one will not happen. This one will not happen. This one is happen because it has the least energy. The least energy is required. So the energy involved here, the 2, they are higher than the energy involved for a copper anode to dissolve and to form, by losing electron, to form copper 2 ion. So this, the least energy is required. So this is what will happen. So if you are write the equation at the anode, this is the equation you are going to write at the anode. Copper 2 minus 2 electron will copper 2 ion. So because SO4 2 minus will not discharge, OH minus will not discharge. So what will happen is copper 2 ion will go into the solution to form copper anode will dissolve in copper 2 sulfate solution to replace copper 2 lost copper 2 ion. This is the reaction that occurs at the anode. So at the anode now, please take note of that. The reaction that will occur is this. This is the reaction that occurs at the anode. Take note of that. So, no one will discharge out of the two. So what will happen at the cathode? The copper anode will dissolve, will go into the solution to form copper 2 ion. This is anodic reaction. So it will now the resulting solution contains the following. It will still contain hydrogen, because at the cathode copper 2 ion has been discharged. So at the anode, no ion is discharged. So SO2 minus it containing, OH minus will contain it, and also this one discharged at the cathode, but the anode dissolve into the solution, goes into the solution to form copper 2 ion. So we still have this. So all these are present, so that the resulting solution will be, resulting solution is still copper 2 sulfate, with the color still remain blue, no color change. The concentration remain intact, because we still have copper 2 sulfate. Please take note of that. So if I have to put this in a tabular form, it will be in this form. I have to put it in a tabular form. So I will say electrolyte, copper 2 sulfate solution. You have the anode cathode here. You have the cathode, it's made of copper. We have the anode. It's made of copper. We have element deposited at, or the products, let me just say the products, products obtained at the cathode, products at the anode. So what the product at the cathode? You have copper is deposited. What's the product at the, so you have Cu. What's the product at the, you have Cu2 plus. So the resulting solution, let's see resulting solution still remain copper 2 sulfate. Is there any color change? Color? No color change. The color still remain blue. Before electrolysis, copper 2 sulfate is blue. After electrolysis, is blue. Then is there any change in pH? / concentration? No change. Constant. Does not change. Is example 2. Electrolysis of sodium chloride solution. Using mercury electrodes. Using mercury electrodes. This also illustrates how the nature of the electrodes affect preferential discharge of ion during electrolysis. So let's see what will happen here. Chemistry of reaction. So now this is sodium ion plus chloride ion, that's ionization. Then you consider water, hydrogen ion plus chloride plus hydroxy ion. So what happens at the cathode and what happens at the anode? So at the cathode, sodium ion and hydrogen ion migrate to the cathode, where hydrogen is expected to discharge because it is below sodium. But due to the nature of the electrolyte, sodium has high affinity for mercury. So instead of that, sodium will quickly react with mercury. Please take note of that. So for that reason, sodium ion is preferentially discharged due to the nature of the electrode, because you are using mercury. So sodium ion will discharge plus electron like this. We gain electron and become sodium. So sodium will now react with mercury to form sodium amalgam. This is known as sodium amalgam or amalgamated sodium amalgam or amalgamated sodium, or you call it amalgamated sodium from sodium amalgam. So this is the product at the cathode. Because sodium has high affinity for mercury, you can easily form amalgam with mercury. So this is what will happen at the cathode. So at the anode, you can let's put anode here. At the anode, let me complete it here. At the anode, what will migrate to the anode? We have chloride ion and OH minus. No normal thing will happen because you are using sodium chloride solution. So OH is below, is preferentially discharged because it is below chloride ion in the chemical series. So OH minus 4 electron here. Remember, this one will give 2 mole of water, then plus oxygen gas. So the principal gas liberated at the anode still remain oxygen, which rekindles a glowing splint. With these two examples, we have come to the end of nature of the electrodes. So these are the factors affecting preferential discharge of ions during electrolysis. Please like, share, comment, and subscribe. God will bless you as you do that.